The oceans are rising. The air is changing. Entire species are disappearing before most people even learn their names. And the strangest part is this. Earth has survived extinction events before. But this time, the danger is coming from inside the system itself. Right now, the planet beneath your feet is slowly becoming harder for humans to survive. Not tomorrow. Not centuries from now. For most of human history, Earth felt permanent, stable, ancient, bigger than us. Civilizations collapsed, wars came and went, empires vanished into dust, but the planet remained. Mountains stood where they always stood. Oceans moved with familiar tides. Seasons returned on schedule like clockwork. That illusion is breaking apart. Scientists now track thousands of changes happening across Earth at the same time. Glaciers that existed before the pyramids are collapsing into the sea. Forests older than human language are burning in weeks. Entire coastlines are sinking. The oceans are warming faster than many climate models predicted. Animals are changing migration routes because the temperature patterns they relied on for millions of years no longer exist. And underneath all of it is a terrifying truth most people never think about. Earth was never designed to stay comfortable forever. Our planet is not a safe place that suddenly became dangerous. It has always been violent, always changing, always moving toward the next transformation. Humans just happened to appear during one of the rare calm periods in its history. A calm period that may already be ending. If you could watch Earth from space over millions of years in just a few minutes, it would look alive. Continents sliding across the surface like broken ice. Giant storms swallowing oceans. Ice sheets expanding and retreating like breathing lungs. Forests appearing, vanishing, then returning somewhere else entirely. Nothing on Earth stays still. Even now, the ground under your feet is moving. North America drifts a few centimeters every year. Europe and Africa slowly push toward each other. The Atlantic Ocean gets wider while the Pacific slowly shrinks. Deep beneath the surface, giant rivers of molten rock circulate endlessly through Earth's mantle, carrying continents like slow-motion conveyor belts. The planet you know today is temporary, and humanity built its entire civilization as if temporary things would last forever. Most cities were designed around stable coastlines, stable temperatures, predictable rain, reliable growing seasons. Entire economies depend on assumptions about nature that are starting to fail. The scary part is not one single disaster. It is the combination of everything happening at once. The atmosphere traps more heat every year. Oceans absorb most of it silently. Coral reefs bleach and die. Fish populations move toward colder waters. Insects disappear from ecosystems that depended on them. Massive wildfires release even more carbon into the atmosphere, creating feedback loops scientists still struggle to fully predict. People often imagine climate change as one event, one catastrophe, one tipping point. Reality is messier. It is thousands of small changes stacking on top of each other until entire systems stop working the way they used to. A river dries earlier than normal. Crops fail in one region. Food prices rise somewhere else. Political instability follows. Migration increases. Infrastructure breaks under extreme weather. Insurance companies leave entire states because rebuilding becomes too expensive. And all of it connects together. Earth works like a machine with billions of moving parts. The atmosphere, oceans, forests, ice caps, animal populations, soil bacteria, ocean currents. Every system affects another system. Change one thing enough, and the consequences spread outward in ways nobody fully controls. One of the clearest examples sits at the top of the world. The Arctic is warming nearly 4 times faster than the global average. Huge areas of sea ice that reflected sunlight back into space are disappearing. Dark ocean water absorbs more heat instead, accelerating warming even faster. This creates a dangerous cycle. Less ice means more heat. More heat means less ice. And the Arctic does not stay in the Arctic. Changes there affect weather patterns across the entire planet. Jet streams weaken and become unstable. Heat waves last longer. Storm systems stall over regions for days instead of moving normally. Some scientists believe this is one reason extreme weather events now seem more chaotic and unpredictable than they did decades ago. Then there is Greenland. Buried under Greenland is enough ice to raise global sea levels by more than 7 meters if it completely melts. Scientists once believed this would take thousands of years, even under severe warming. Now, some parts of Greenland are melting much faster than expected. Entire rivers form on top of the ice during summer. Lakes suddenly drain through cracks and disappear into the glacier below. Massive chunks of ice break off into the ocean with enough force to register as earthquakes. The scary thing about ice sheets is that they do not melt smoothly. They can reach tipping points. For years, they appear stable. Then suddenly, the structure weakens enough that collapse speeds up dramatically. Like cracking glass spreading faster after the first fracture appears, scientists worry parts of Antarctica may already be approaching similar thresholds. West Antarctica contains glaciers large enough to permanently reshape coastlines around the world. If certain ice shelves collapse, they stop holding back inland glaciers. Ice flows faster into the ocean. Sea levels rise not by centimeters over centuries, but potentially by meters over much shorter periods. Imagine what that means. Cities like Miami, Jakarta, Bangkok, Alexandria, Shanghai, Mumbai, and parts of New York exist because sea levels remained relatively stable during human civilization. Ports, roads, airports, power systems, freshwater supplies, all built near coastlines. Now the coastlines themselves are moving, and unlike storms or earthquakes, sea level rise does not end after the disaster passes. Water keeps coming higher year after year. Some island nations already discuss evacuation plans for entire populations. Not because of war, not because of economic collapse, because their countries may literally disappear beneath the ocean. But rising seas are only one piece of the story. The atmosphere itself is changing in ways humans can physically feel. Heat waves that once happened once every 50 years now happen far more often in many regions. Some places record temperatures so high that roads soften, train lines bend, and outdoor labor becomes dangerous for hours at a time. Humidity makes it worse. Humans cool themselves through sweat evaporating from skin. But when humidity rises too high, evaporation slows. The body traps heat internally. At extreme wet bulb temperatures, even healthy people resting in shade can die after several hours because the body simply cannot cool itself fast enough. Some regions near the equator may approach these dangerous limits more frequently in coming decades. That matters because hundreds of millions of people live there, and heat affects more than comfort. Crops have temperature limits. Infrastructure has temperature limits. Electrical grids fail under extreme demand for cooling. Water evaporates faster from soil. Droughts intensify. Wildfire seasons grow longer. Fire itself is becoming one of the defining images of modern Earth. Forests that evolved to survive occasional fires are now experiencing megafires so intense they destroy the soil itself. In some places, trees may not grow back for generations. Smoke crosses continents. In recent years, satellite images showed smoke from massive wildfires traveling thousands of kilometers across oceans, turning skies orange. Far away from the original flames, the planet feels connected in a new way now. A drought in one region affects food prices elsewhere. Fires alter atmospheric chemistry. Ocean warming changes storm intensity across entire hemispheres. And still, beneath all this, Earth keeps moving according to forces far older than humanity. Take the moon. Most people think of the moon as something peaceful, a silent object hanging in the night sky. But the moon is deeply tied to Earth's stability. Without it, our planet might be almost unrecognizable. The moon stabilizes Earth's axial tilt. That tilt controls seasons. Without the moon, Earth's tilt could wobble chaotically over time. Some models suggest the planet could swing between extreme climate states far more violently. The moon also controls tides, influencing ocean circulation and coastal ecosystems. Life itself may have developed differently without those tidal forces billions of years ago. But here is the strange part. The moon is slowly moving away from Earth. Every year, it drifts roughly 3.8 centimeters farther away. Tiny, almost nothing. But over millions and billions of years, the effect becomes enormous. Long ago, the moon looked much larger in Earth's sky. Days on Earth were shorter too. The planet spun faster. Over time, tidal interactions transferred energy from Earth's rotation into the moon's orbit, slowing Earth's spin while pushing the moon farther away. Right now, days continue getting longer very slowly. Not enough for humans to notice during a lifetime, but enough that scientists can measure it with incredible precision. Earth is not frozen in place. It is part of a constantly evolving gravitational dance. And the future of that dance is brutal. Hundreds of millions of years from now, the continents may merge again into another supercontinent. Ocean currents would change completely. Massive interior deserts could form. Evolution would push life into strange new directions. But humanity will likely face severe challenges long before then, because Earth's greatest long-term threat hangs much closer than most people realize. The sun, every second, the sun converts around 600 million tons of hydrogen into helium through nuclear fusion. That reaction releases the energy keeping Earth warm enough for life. Without the sun, Earth becomes a frozen dead world almost immediately. But stars do not stay constant forever. As the sun ages, it slowly grows brighter, not dramatically over human timescales, but over geological timescales, enough to change everything. Billions of years ago, the sun was dimmer than today. Early Earth survived partly because greenhouse gases trapped extra heat. As the sun slowly brightened, Earth remained habitable through a delicate balance of atmospheric and geological processes. But that balance cannot last forever. In roughly 1 billion years, the sun may become bright enough that Earth's oceans begin evaporating rapidly. Water vapor itself is a greenhouse gas, trapping more heat and accelerating warming further. The oceans that gave birth to life could eventually boil away into space. Before that happens, complex life on Earth may already disappear. Plants would struggle, food chains collapse, surface temperatures rise beyond what most organisms can tolerate. The biosphere shrinks toward the poles and underground environments before vanishing almost entirely. And this is not science fiction. This is simply stellar evolution. The terrifying thing is how temporary habitable planets truly are. Earth feels eternal because human lives are short. But planets have lifespans too. Even now, our world exists in a narrow window where liquid water, atmospheric chemistry, temperature, magnetic protection, and orbital stability all align closely enough for advanced life. That window eventually closes, and Earth has faced catastrophe many times before. About 66 million years ago, an asteroid around 10 kilometers wide slammed into the region now called Mexico. The impact released more energy than billions of nuclear bombs. The dinosaurs never recovered. Shockwaves circled the planet. Wildfires spread globally. Dust and sulfur blocked sunlight. Temperatures crashed. Food chains collapsed. Around 75% of species disappeared. What scares scientists is not just that impacts happened in the past. They will happen again. Earth moves through a cosmic shooting gallery filled with asteroids and comets. Most are harmless. Some burn up in the atmosphere, but large impacts remain inevitable over long enough timescales. NASA tracks thousands of near-Earth objects now. Many pose no danger. Some require monitoring. Planetary defense systems improve every year, but space is enormous and detection is imperfect. A sufficiently large impact today could destabilize global civilization even without causing human extinction directly. Modern civilization depends on interconnected supply chains, satellites, communication systems, agriculture networks, and energy infrastructure. We are technologically advanced, but also deeply fragile. A single global catastrophe could trigger cascading failures faster than ancient societies ever experienced. And sometimes the danger does not come from space. Sometimes it comes from beneath our feet. Earth's crust floats on tectonic plates that constantly move and grind against each other. That movement creates earthquakes, volcanoes, and mountain ranges. Human civilization developed during an unusually calm geological period compared to many eras in Earth's past. But the planet still reminds us who controls the surface. Supervolcanoes exist beneath places like Yellowstone. Most scientists believe the risk of eruption in any given century remains low. But if one occurred, consequences would be severe. Ash clouds could disrupt global agriculture. Temperatures might temporarily drop worldwide. Then there are underwater volcanoes and fault systems capable of generating tsunamis powerful enough to erase entire coastlines within hours. Earth is calm until suddenly it is not. That pattern repeats through history. Civilizations often assume the conditions they grew up with are normal forever. Then nature changes the rules. Ancient droughts may have contributed to the collapse of entire empires. Volcanic eruptions altered climates for years. Disease reshaped continents. Crop failures triggered wars and migration. Now humanity faces global environmental pressure on a scale no civilization has ever experienced simultaneously. And despite all our technology, we still depend on incredibly basic things: stable temperatures, clean water, reliable food, predictable seasons, healthy ecosystems. Remove those long enough, and advanced civilization becomes much harder to maintain. One of the most overlooked crises happening right now is biodiversity collapse. Species are disappearing at rates many scientists compare to past mass extinctions. Not just famous animals like tigers or rhinos, insects, amphibians, fish, birds. Tiny organisms most people never notice. This matters because ecosystems depend on relationships built over millions of years. Pollinators help crops reproduce. Predators control populations. Forests regulate rainfall and store carbon. Ocean plankton produce huge amounts of Earth's oxygen. Nature is not decoration around human civilization. It is the support system underneath it. And many of those systems are under pressure simultaneously. Rainforests shrink while oceans acidify. Rivers carry pollution into seas. Plastic spreads through food chains. Soil loses nutrients through overuse. Groundwater reserves drain faster than they refill. Some scientists warn humanity may be crossing planetary boundaries faster than expected. And still, everyday life often feels normal. People go to work, kids go to school, traffic fills highways, stores stay stocked, phones buzz with notifications. Civilization is strange like that. Huge systems can appear stable right until they suddenly are not. Financial crashes work this way. Ecosystems work this way. Empires work this way. For years, warning signs build quietly in the background while most people continue daily routines. Then one day, everyone realizes something fundamental has changed. The truth is, Earth does not care about human plans. Nature is not cruel. It is indifferent. The atmosphere follows physics. Oceans follow chemistry. Gravity follows mass. Evolution follows survival. Human emotions do not change these systems. And yet humans remain one of the most unusual things Earth has ever produced. In just a few thousand years, a species of primates learned to reshape entire continents. We built cities visible from space, split the atom, walked on the moon, connected billions of minds through invisible digital networks. Human intelligence became a geological force. Scientists now use the term Anthropocene to describe how strongly human activity influences Earth itself. Future geologists, millions of years from now, may see clear evidence in rock layers showing the period when humans transformed the atmosphere, oceans, and ecosystems. That realization changes how we see ourselves. We are not outside nature, observing it safely from a distance. We are part of the system, and systems can become unstable. One major concern scientists study is tipping points. These are thresholds where gradual change suddenly triggers rapid transformation. Imagine pushing a glass slowly toward the edge of a table. For a long time, nothing dramatic happens. Then suddenly gravity takes over and the glass falls. Climate systems may behave similarly. Permafrost contains enormous amounts of frozen carbon and methane. If enough thawing occurs, those gases enter the atmosphere, causing more warming, which causes more thawing. The Amazon rainforest creates much of its own rainfall through evaporation. Lose enough forest, and rainfall patterns may weaken enough that large regions shift toward dry grassland. Ocean circulation systems may also weaken under certain conditions. One of the most famous is the Atlantic Meridional Overturning Circulation, often linked to the Gulf Stream system. It helps move heat around the planet. Some studies suggest melting fresh water from Greenland could weaken parts of this circulation over time. the full consequences remain uncertain. And uncertainty itself is frightening, because uncertainty means scientists cannot guarantee how bad things could become. Still, Earth has another side people often forget. Resilience, life survived asteroid impacts, supervolcanoes, ice ages, radiation bursts, and mass extinctions. Again and again, evolution rebuilt ecosystems from catastrophe. After the dinosaur extinction, mammals eventually spread across the planet. After massive volcanic events darkened skies, life adapted. Earth is incredibly good at continuing. The real question is whether human civilization can adapt fast enough to the changes happening now. Because humans evolved for smaller worlds. Our brains struggle with slow-moving global threats. We react strongly to immediate danger, predators, violence, sudden disaster. But gradual planetary change feels abstract until consequences become personal. A wildfire reaches your town, a flood destroys your home, a heat wave kills crops. A drought empties reservoirs. Then suddenly, the crisis feels real. One reason modern climate discussions become so emotional is because they collide with identity, politics, economics, and fear about the future itself. People want certainty. But Earth does not offer certainty, only probability. And probability says the coming centuries may transform civilization more dramatically than most people alive today can fully imagine. Some regions could become more habitable, while others become harder to survive in. New technologies may reduce emissions or remove carbon. Energy systems may change completely. Artificial intelligence, biotechnology, and space industries may alter humanity's trajectory in ways impossible to predict fully right now. The future is not written yet. But physics still sets limits. You cannot negotiate with thermodynamics. You cannot vote against sea level rise. You cannot argue with atmospheric chemistry. The laws governing Earth existed long before humanity and will continue long after us. And maybe that is what makes this moment feel so unsettling. For centuries, humans believed progress meant increasing control over nature. Bigger cities, more machines, more energy, more expansion. Now, we are discovering the system itself has boundaries. Cross them too aggressively, and the environment responds. Not out of revenge, just cause and effect. There is another uncomfortable truth buried inside all of this. Human civilization depends on an extremely thin layer of habitability. Most life exists within a narrow band near Earth's surface. A few kilometers upward, conditions become deadly. A few kilometers downward, heat and pressure become unbearable. Earth's biosphere is like a fragile skin, wrapped around a giant ball of molten rock, moving through empty space. Everything humans have ever loved exists inside that thin layer. Every song, every language, every war, every child, every memory, every dream. And above it hangs an atmosphere thinner than the skin on an apple. That atmosphere protects us from radiation, regulates temperature, and carries the oxygen keeping us alive. Without it, Earth becomes another dead rock in space. Astronauts often describe seeing Earth from orbit as psychologically overwhelming. Borders disappear. Politics vanish. The planet looks small, isolated, vulnerable, a bright blue sphere floating in darkness. No backup world waits nearby. Mars is hostile. Venus is hellish. The outer planets are frozen wastelands. Earth remains the only known planet in the universe confirmed to support complex life. And, despite all our problems, it is still astonishingly beautiful. Forests breathing in sunlight, storms swirling across oceans, cities glowing at night, whales crossing entire seas, lightning flashing inside giant clouds visible from space. The same planet capable of earthquakes and extinctions also produced consciousness able to study stars and wonder about existence itself. That contradiction sits at the center of being human. We are powerful enough to reshape the world, but fragile enough to disappear from it. Some scientists believe humanity stands at a crossroads similar to earlier turning points in evolution. A species capable of planetary-scale influence must eventually learn planetary-scale responsibility. Otherwise, civilization may destabilize itself faster than it can adapt. The danger is not necessarily one giant apocalypse movie scenario. It is erosion, gradual pressure, chaos stress spite rask failures, political instability triggered by environmental change, migration crises, economic shocks, regional conflicts intensified by scarcity. The future may arrive through accumulation instead of explosion. And yet people continue building, inventing, discovering. That may be the most human thing of all. Even during uncertainty, humanity keeps moving forward. New energy technologies emerge. Fusion research advances slowly. Scientists develop better climate models. Engineers design carbon capture systems. Conservation efforts restore some damaged ecosystems. International cooperation, while imperfect, still exists. The story is not finished. But Earth itself will continue changing no matter what humans do. Eventually, the continents shift again. Eventually, the sun grows hotter. Eventually, the oceans disappear. Eventually, even Earth may become unrecognizable. In about 5 billion years, the sun will expand into a red giant star. Its outer layers may reach or even consume the inner planets. Mercury likely disappears. Venus almost certainly dies completely. Earth's exact fate remains uncertain. Some models suggest the planet could be swallowed by the expanding sun. Others suggest it may survive briefly as a scorched, molten world orbiting a dying star. Either way, the oceans vanish long before that. The atmosphere burns away. The surface melts. Everything humans ever built disappears. No cities, no monuments, no evidence of civilization visible anymore. Just rock and fire beneath a swollen red sky. And after the sun finally sheds its outer layers, a white dwarf will remain slowly cooling for trillions of years in darkness. The future of Earth ends not with an explosion, but with silence. But that future is unimaginably far away. The closer reality is this. Human civilization exists during one tiny moment when Earth is still rich with life, liquid oceans, breathable air, and stable enough conditions for billions of people to survive. That moment is precious and fragile, because the same planet that created humanity can also erase it. Not out of hatred, just physics, just time, just the endless process of change that shaped Earth long before the first human looked at the stars and wondered how long any of this could last. Most people imagine the end of Earth as one dramatic moment, a giant explosion, a massive asteroid, one final disaster where everything suddenly goes dark. But the real end of worlds is usually slower than that. Planets die by inches, a little more heat every century, a little less ice every decade. A few more species disappearing every year until ecosystems stop functioning the way they once did. And humans are very bad at noticing slow disasters, while they are happening. If a mountain exploded tomorrow, the entire planet would panic instantly. But if oceans slowly warm for 50 years, cities adapt little by little, people argue online, politicians delay action, companies continue operating, and normal life keeps moving right up until the damage becomes impossible to reverse. That is where Earth feels strange right now. The planet still looks normal enough for daily life to continue. But underneath that normality, systems are shifting. Some of the changes are already visible from space. Satellite images now show forests thinning across entire continents. Massive reservoirs shrinking. Ice vanishing from mountain ranges that once supplied fresh water to hundreds of millions of people. Even the color of Earth is changing in some regions. Certain parts of the oceans are becoming less productive biologically because warming water mixes differently than colder water. That affects plankton populations near the surface. And plankton matter far more than most people realize. Tiny ocean plankton help produce a huge percentage of Earth's oxygen. The air you breathe partly comes from organisms so small they are nearly invisible. That is the thing about Earth. The biggest systems often depend on the smallest pieces. Remove enough insects and birds disappear. Roam enough plankton and fisheries collapse. Dist enough forests and rainfall patterns change thousands of kilometers away. Everything is connected through chains people rarely notice until the chain breaks. One example is happening with bees. For years, scientists tracked worrying declines in bee populations across different regions. Habitat destruction, pesticides, disease, and climate stress all played roles. At first, this sounded like a small environmental story. Then people realized bees pollinate crops humans depend on: fruits, vegetables, nuts. Entire agricultural systems rely on pollinators. When ecosystems weaken, civilization feels it later through food supply, economics, and health. And Earth keeps delivering reminders that humans are not separate from nature. During extreme heat events, some birds literally fall out of the sky because temperatures become too high for survival. Fish die in rivers where oxygen levels crash during heat waves. Coral reefs bleach white across huge regions of the ocean. Coral reefs are sometimes called the rainforests of the sea because of how much life depends on them. Millions of species use reef systems for shelter, breeding, or food, and reefs are highly sensitive to temperature changes. Just a few degrees of warming can push corals past survival limits. The tragedy is how quiet reef death looks from above. No explosions, no dramatic sound. Just color slowly draining away from structures that took thousands of years to grow. Scientists who revisit reefs they studied decades ago sometimes describe the experience almost like visiting a graveyard. Places once filled with movement and color become silent underwater deserts. The oceans themselves hold another danger most people never think about: acidification. As oceans absorb carbon dioxide from the atmosphere, seawater chemistry changes. It becomes more acidic. Small changes in pH can affect shell-building organisms like plankton, mollusks, and corals. And because marine food chains begin with tiny organisms, disruptions spread upward through the system. Human civilization often treats nature like a background image, something decorative. But the biosphere is infrastructure, more important than roads, more important than stock markets, more important than governments. Without functioning ecosystems, modern civilization becomes impossible. That sounds dramatic until you realize how dependent humans are on stable environmental conditions. Take soil. Healthy soil contains enormous networks of fungi, microbes, insects, nutrients, water channels, and organic material. It is alive in ways people rarely think about, but modern agriculture can damage soil over time through erosion, overuse, and chemical imbalance. Some scientists warn parts of the world are losing fertile topsoil much faster than nature can replace it. Civilizations throughout history already learned this lesson the hard way. Regions once capable of feeding huge populations eventually became barren after environmental collapse combined with poor resource management. Nature gives warnings long before total failure, but humans often ignore warnings during periods of growth. And modern civilization grew faster than any civilization in history. In only a few generations, humans covered the planet with highways, airports, shipping lanes, data centers, factories, skyscrapers, satellites, and power grids. The scale is almost unbelievable. Every day, thousands of massive cargo ships move goods across oceans. Airplanes cross the sky every few seconds. Financial markets transfer trillions of dollars digitally. Electricity powers billions of devices simultaneously. The system feels unstoppable. But complex systems are rarely as strong as they appear. One disruption spreads into another. A drought affects crops, food prices rise, governments react. Supply chains strain, energy demand increases, political instability grows. Migration rises, markets panic. Modern civilization is deeply interconnected, which makes it efficient but also vulnerable. People discovered this during global pandemics. Tiny disruptions suddenly created shortages everywhere. Ports clogged, factories stopped, transportation systems slowed, hospitals overflowed. Now imagine environmental disruptions happening continuously for decades. Not one crisis, several at once. Heat stress, water shortages, crop failures, extreme storms, Badgeristrock damage, mass displacement, insurance collapse in vulnerable regions. This is why some scientists worry less about one giant apocalypse and more about systemic instability. Civilizations do not need total extinction to suffer enormous damage. History proves that repeatedly. The Roman Empire did not vanish overnight. It weakened gradually through economic pressure, political fragmentation, resource problems, disease, and external threats. The Maya civilization experienced severe environmental stress connected partly to drought. Ancient Mesopotamian societies struggled with soil salinization after irrigation systems altered farmland chemistry over time. Nature has always influenced human history. The difference now is scale. For the first time, one species affects the entire planet at once. And humans built civilization during an unusually stable climate period known as the Holocene. That stability allowed agriculture to flourish. Cities expanded. Populations exploded. Predictable seasons helped civilizations plan years ahead. But geological history shows Earth rarely stays stable forever. Ice ages come and go. Ocean circulation shifts, atmospheric chemistry changes, extinction events reset ecosystems. The calm period humans depended on may be more fragile than people once believed. One reason climate scientists sound increasingly concerned is because observations sometimes move faster than old predictions. Wildfires become larger. ice loss accelerates, marine heat waves intensify, storm rainfall grows heavier, and the atmosphere now contains more carbon dioxide than at any point in human civilization. Some researchers compare modern atmospheric change to ancient periods associated with massive ecological disruption. What makes this different from ancient climate shifts is speed. Natural climate transitions often unfolded across thousands of years. Human activity altered atmospheric chemistry dramatically in just a couple centuries. Evolution adapts slowly. Bite-Stroxel adapts slowly. Political systems adapt slowly. Physics does not slow down to wait. There is another invisible shield protecting Earth that people almost never think about. The magnetic field deep inside Earth. Molten iron moves through the outer core, generating a magnetic field surrounding the planet. This field protects life from charged particles coming from the sun and deep space. Without it, radiation exposure at Earth's surface would rise dramatically. The atmosphere itself could slowly erode over long timescales. Mars may have lost much of its atmosphere partly because it lost a strong global magnetic field long ago. Earth's magnetic field is not permanent either. It shifts constantly. Magnetic north moves over time. Even stranger, the field occasionally flips completely. North becomes south. South becomes north. Scientists know this happened many times throughout geological history because magnetic signatures remain trapped inside ancient rocks. A magnetic reversal would not instantly destroy life, but it could temporarily weaken Earth's protective shield during the transition. Modern civilization depends heavily on satellites, electrical systems, and communications technology vulnerable to radiation storms. And the sun itself can produce terrifying eruptions. Solar flares and coronal mass ejections sometimes blast huge amounts of charged particles into space. Most are harmless to humans on the ground because Earth's magnetic field protects us. But extremely powerful solar storms could severely damage electrical infrastructure and satellites. In 1859, the Carrington event created auroras visible near the equator and disrupted telegraph systems worldwide. Operators reported sparks flying from equipment. That happened before modern electronics existed. A similar event today could potentially disrupt power grids, internet infrastructure, GPS systems, aviation, banking, communications, and supply chains across huge areas. Modern civilization is technologically advanced. It is also incredibly exposed. The more connected the system becomes, the more vulnerable it becomes to disruption. Even space itself is becoming crowded. Thousands of satellites now orbit Earth. Space debris races around the planet at terrifying speeds. Tiny fragments can damage spacecraft because orbital velocities are so extreme. Humanity expanded into near-Earth space faster than most people realize. And yet Earth remains trapped inside a larger cosmic environment we barely control. Every night, invisible particles from distant stars pass through your body. Radiation from ancient supernova explosions still travels across the universe. Black holes collide billions of light years away. Galaxies crash into each other over millions of years. The universe is violent on scales difficult for the human brain to fully understand. Earth survives partly because space is mostly empty, but not completely empty. Rogue asteroids still move silently through darkness. Some are large enough to destroy cities. Others could affect entire continents. A truly massive impact could alter civilization itself. The asteroid that killed the dinosaurs changed the course of evolution forever. If that asteroid missed Earth, mammals might never have become dominant life forms. Humans might never exist. That single impact shaped the future of the planet more than almost any event in Earth's history. And there have been other close calls. In 2013, a relatively small meteor exploded over Chelyabinsk, Russia. The blast shattered windows across the city and injured more than 1,000 people, mostly from broken glass. That object was tiny compared to extinction-level asteroids. Space does not need to hit Earth directly to become dangerous either. Gamma-ray bursts, supernova radiation, and other cosmic events have been studied as possible contributors to past extinction events. Though evidence remains uncertain in many cases, the point is simple. Earth is not protected from the universe. It exists inside it. And despite all the dangers humans imagine on Earth, space itself is often far more hostile. This makes life on our planet even more extraordinary. As far as scientists currently know, complex life may be extremely rare. The universe contains hundreds of billions of galaxies. Each galaxy contains enormous numbers of stars and planets. Yet humans still have no confirmed evidence of another advanced civilization. That silence unsettles some scientists deeply. It raises a disturbing possibility. Maybe intelligent civilizations are fragile. Maybe most destroy themselves. Maybe environmental collapse, resource wars, artificial intelligence, pandemics, or technological instability prevent civilizations from surviving long enough to spread across the stars. This idea is sometimes connected to the Fermi paradox. If the universe should contain advanced civilizations, where is everybody? No signals, no probes, no giant visible structures, just silence. One explanation is distance. Another is timing. But another possibility is that surviving technological adolescence is extremely difficult. Humanity now has tools powerful enough to reshape the planet, manipulate genetics, automate warfare, and alter the atmosphere. Wisdom has not necessarily evolved as fast as technology, and Earth keeps reminding humans that survival is never guaranteed. In some regions, groundwater is disappearing faster than it can refill naturally. Ancient underground water reserves, built over thousands of years, are being drained for agriculture and cities. Some rivers no longer reliably reach the ocean during parts of the year because so much water gets diverted. Large lakes shrink dramatically during prolonged droughts. Water may become one of the defining pressures of the future, not because Earth lacks water overall, but because drinkable fresh water exists in limited, accessible forms. Glaciers act like giant natural reservoirs, slowly releasing water during warmer months. But many glaciers around the world are retreating rapidly. For hundreds of millions of people, glacier loss threatens long-term water stability. And then there are storms. Warmer air holds more moisture. That can intensify rainfall during certain weather events. Flooding becomes more severe. Hurricanes and typhoons can carry enormous amounts of energy from warm oceans. Some storms now rapidly intensify so quickly that forecasting becomes harder. Cities built for older climate patterns suddenly face conditions infrastructure was never designed to handle. Drainage systems fail, roads collapse, power grids shut down. and rebuilding becomes more expensive every year. Insurance companies already track climate risk intensely because money notices patterns quickly. In some vulnerable regions, insurance costs rise dramatically or coverage disappears entirely because repeated disasters become financially unsustainable. That changes where people can realistically live. The future of Earth may reshape geography, not through borders first, but through habitability. Some places become too hot, others too dry, others too flood-prone. Migration pressures increase, political tensions rise. The environmental crisis is also a human crisis because civilization and nature were never separate systems to begin with. One of the strangest psychological effects of modern life is how disconnected people became from the physical planet supporting them. Food appears in supermarkets disconnected from soil and weather. Electricity arrives through invisible systems most people never see. Water flows from taps without reminding people where reservoirs come from. Cities create an illusion of independence from nature. But one major disruption reveals the truth immediately. No electricity for several days changes everything. No clean water changes everything. No food shipments change everything. Modern civilization depends on constant hidden stability, and maintaining that stability becomes harder on a stressed planet. Yet there is another side to humanity that should not be ignored. People adapt. Again and again throughout history, humans survived impossible situations through cooperation, innovation, and persistence. Entire cities rebuilt after destruction. Diseases were cured. Technologies transformed societies. Life expectancy increased dramatically compared to earlier centuries. The same species capable of damaging ecosystems is also capable of understanding them. That matters, because awareness changes behavior. Renewable energy expanded far faster than many experts predicted decades ago. Solar and wind technology improved rapidly. Battery storage continues advancing. Scientists develop better methods for monitoring environmental change. Young generations increasingly grow up understanding planetary systems in ways previous generations often did not. The future is not guaranteed to collapse, but neither is it guaranteed to remain stable. Earth is entering a period of transformation, and humans are inside the transformation, not outside observing safely from a distance. One day, future historians, if humans still exist far in the future, may look back at this century as the moment civilization realized the planet had limits, not symbolic limits. Physical ones, atmospheric limits, dual limits, ecological limits, energy limits. And the response to those limits may shape the next 1,000 years of human history. Because if civilization survives long enough, humans may eventually spread beyond Earth. Moon colonies, Mars settlements, artificial habitats in space. Perhaps one day entire cities floating between worlds. But even if humanity becomes multiplanetary, Earth will remain the birthplace, the original home. The only world known to naturally create forests, whales, thunderstorms, birdsong, rivers, insects, trees, and conscious beings capable of asking questions about existence. That alone makes Earth rare beyond comprehension and fragile. People often talk about saving the planet, but the planet itself will survive in some form no matter what humans do. Earth endured asteroid impacts, supervolcanoes, ice ages, and mass extinctions long before humans appeared. The real question is, what kind of planet remains for future generations of life? And whether human civilization remains part of that future. Because extinction is normal in Earth's history. More than 99% of all species that ever lived are gone. Entire branches of evolution vanished forever. The dinosaurs ruled Earth for around 165 million years. Humans have existed for only a tiny fraction of that time. Civilization itself is incredibly young. Modern industrial society is basically a blink of an eye compared to geological history. And yet within that blink, humans altered the atmosphere enough to be measurable globally. That is extraordinary power, possibly dangerous power, especially because human brains evolved for tribal survival, not planetary management. People struggle to cooperate, even inside single countries. Now, imagine coordinating billions of humans with competing interests, economies, religions, and political systems while facing long-term environmental pressure. It may become one of the hardest challenges any intelligent species can face. Not defeating nature, learning how to exist inside it without destabilizing the systems keeping civilization alive. And Earth keeps moving forward regardless. Continents drift, species evolve, stars age, the moon slowly pulls away, the sun grows brighter. Time keeps pushing everything toward change. Even mountains eventually disappear. The Himalayas look eternal, but erosion constantly wears them down, while tectonic forces push them upward. Every landscape on Earth is temporary if given enough time. The Grand Canyon exists because water patiently carved rock over millions of years. Deserts expand and shrink, coastlines move. Entire oceans open and close across geological eras. Nothing stays fixed. Humans simply arrived during one chapter of the story and mistook it for permanence. That illusion may be one of the most dangerous ideas civilization ever created, because permanence encourages carelessness. People protect what they understand is fragile. And Earth is fragile, not weak, not helpless, but delicately balanced, a slightly different orbit, a weaker magnetic field, a larger asteroid impact, a brighter sun earlier in history. Any of those changes might have prevented humans from ever existing. The fact that civilization appeared at all may depend on a chain of unlikely conditions stretching back billions of years. That realization changes how you see the night sky. Every person alive exists because Earth remains stable, long enough for intelligence to evolve. And now, intelligence itself has become part of the planetary system. For better or worse, some scientists think humanity may eventually learn to manage Earth responsibly using advanced technology, global cooperation, and better understanding of environmental systems. Others worry civilization may react too slowly to accumulating stress. Nobody knows for certain. That uncertainty hangs over the future like a shadow. But one thing is already true. The age where humans could ignore planetary systems safely is over. The atmosphere remembers, the oceans remember, ice remembers, forests remember. Fyings remembers every action, whether humans pay attention or not. And still, despite everything, Earth remains breathtaking. Children still laugh on beaches. Rain still falls on forests. Auroras still dance over the poles. Waves still crash against cliffs older than human history. Life still fills the oceans with movement and sound. The world is not dead, far from it, but it is changing, quietly, relentlessly, and faster than many people realize. One day, thousands or millions of years from now, future beings may study the layer of rock representing our era. They may see plastics buried in sediments, chemical traces from industry, sudden extinction patterns, changes in atmospheric composition trapped inside ice and stone. They will know something unusual happened during the age of humans. A species became intelligent enough to reshape an entire world, and then faced the terrifying responsibility that came with it. The next video on your screen explains what scientists believe will happen when the sun finally reaches the end of its life.